Some developers haven't written a line of code in months, and somehow they're shipping faster than ever. Here's what changed. A quiet revolution is happening in software development, and most people haven't noticed yet. The Markdown file has become the source of truth. The code, it's just an implementation artifact now, a byproduct of something more fundamental. But here's where it gets interesting. The documentation itself is also generated through conversation, through iteration, through pushing back until it's exactly right. Think about what this means. For decades, developers sat in front of IDEs, typing syntax, debugging semicolons, wrestling with boilerplate. The measure of a programmer was how fast they could translate ideas into working code. That entire paradigm is dying. The developer's role has fundamentally shifted from writing to directing, from implementing to iterating, from typing to thinking. It's less like being a construction worker, and more like being an architect who can watch buildings materialize in real time based on verbal descriptions. The keyboard hasn't disappeared, but its purpose has changed. Instead of crafting code character by character, developers now craft conversations. They guide, they refine, they decide. But if developers aren't writing code anymore, what exactly are they doing all day? Early adopters have developed a workflow that looks nothing like traditional programming. It has 5 distinct steps, and not one of them involves opening a code editor. Step 1. The brain dump. Stream of consciousness. Misspellings. Run-on sentences. Half-formed thoughts. Just get everything out. The AI handles the mess. Step 2. Demand an architecture plan. Always. Before any code gets generated. This is non-negotiable. Step 3 is where most people fail. Be nitpicky. Obsessively so. Here's something crucial to understand. Large language models struggle with deliberate reasoning. They don't always interpret instructions the way you think you said them. This is where misinterpretations get caught, or where they slip through and haunt you later. Step 4. Iterate until it's exactly right. Never accept the first plan. Keep refining. Push back on approach and structure. Step 5. Let it implement. And here's the rule that breaks most developers' brains. Never manually edit files afterward. Reprompt instead. Every manual edit becomes a bottleneck. Even for tiny changes, reprompting is faster than typing. This feels wrong at first. Decades of muscle memory scream to just fix that one line yourself. But the developers who resist that urge consistently outpace those who don't. This sounds dangerously fast, and that's exactly the problem. Here's a truth that seems backwards until you live it. AI makes planning more important, not less. Most people assume the opposite. If code writes itself, why bother with careful architecture? Just generate something and fix it later. This thinking is a trap. When implementation becomes instant, bad architecture costs you instantly too. You can build the wrong thing in an afternoon, then rebuild it again. The speed that was supposed to save time becomes the engine of waste. Before AI, slow implementation acted as a natural brake. Developers had time to reconsider while typing. Bad ideas revealed themselves during the long slog of coding. That friction is gone now. The bottleneck has shifted entirely. It's no longer about coding speed. It's about knowing what to build. And this is where humans become irreplaceable. Machines can generate solutions at incredible speed, but they can't decide which problems matter. They can't feel the user's frustration. They can't sense when an elegant architecture will become a maintenance nightmare 6 months later. The developers thriving in this new world spend their time thinking, debating, questioning assumptions. They argue with the plan before any code exists. Because once generation starts, you're already committed. Most developers are making 3 critical mistakes that waste this superpower entirely. Mistake number 1. Asking for too little. Developers remain shackled by old limitations. They request small changes, because that's what was possible before. Fix this function. Adjust that variable. These incremental asks waste the technology's actual capability. The ceiling is vastly higher now. Entire features. Complete systems. The developers seeing real productivity gains. Describe whole architectures in single conversations, and watch them materialize. Mistake number 2. Under-documenting. For years, documentation was expensive. Write the code, then spend hours explaining it. Nobody wanted to do that. Now documentation is nearly free. And here's the insight that changes everything. That architecture.md file isn't for humans. It's for the AI's long-term memory. Between sessions, models forget everything. That documentation is how the next conversation knows what was built before. Under document, and every new session starts from zero. Mistake number 3. Forcing AI code to match human formatting preferences. Stop trying to make generated code look like code you would have written. The old aesthetic standards, the particular indentation, the specific naming conventions you preferred, none of it matters anymore. Nobody reads code line by line now. It gets read and edited agentically. Clinging to old formatting preferences is optimizing for an audience that no longer exists. But here's the question everyone eventually asks. If AI gives different answers every time, how do you possibly test any of this? Testing non-deterministic systems sounds impossible. Ask the same question twice. Get different answers. How do you write assertions against chaos? The solution requires splitting your system intelligently. Design the architecture so AI returns structured data alongside prose, JSON fields, extracted entities, classifications, confidence scores. These are deterministic. Test them traditionally. Write normal assertions. They'll pass consistently. The creative text needs a different approach. For genuinely non-deterministic outputs, use another AI as a judge. Does this reply match the intended tone? Did the summary capture the key points? The judge returns a Boolean or score you can assert against. It sounds circular, but it works. Then there's the ambiguity problem. Consider the prompt. Schedule a meeting with the London team. London, England, or London, Ontario. Both interpretations could be valid depending on context. Tests must accept multiple correct answers when the input is genuinely ambiguous. Forcing a single right answer where none exists creates false failures. One team built over 500 integration tests this way, for a production system, not a proof of concept. Real software, serving real users, tested by methods that didn't exist 3 years ago. But the real surprise wasn't the testing methodology. It was what happened to the developers themselves. Something unexpected happens when the friction disappears. Building software becomes genuinely enjoyable. There's a dopamine rush to this workflow. Describe something, watch it exist minutes later. The feedback loop is fast enough to sustain flow state, that psychological zone, where time disappears and focus becomes effortless. One developer reported replacing 30 hours per week of video games with building software. Not through discipline or willpower, through genuine preference. Shipping features hits the same reward centers as gaming. The same variable rewards. The same sense of progression. The same satisfaction of completion. But faster. The proof is in the output. 380 commits. 5 complete products. Built by 2 people. All created by programming in Markdown. Directing AI through conversations instead of typing syntax. Code review didn't disappear in this new world. It moved up a level. The old way meant reading code line by line, hunting for bugs in logic and syntax. The new way means building integration tests with AI, stepping through features, verifying systems work as intended. Same loop, higher abstraction. You operate from a level up now. The question isn't whether this is the future. That debate ended months ago for developers paying attention. The real question is simpler. Will you spend the next year fighting this transition, or the next month mastering it?